Welcome to today's deep dive. When you watch a massive live broadcast, you're usually focused on like the big visible things, right?
hmm
The multi-million-dollar cameras, the giant production trucks.
Right. Yeah, it's super easy to get distracted by all the heavy gear taking up physical space.
Exactly. But today, we actually have a very specific mission for you. We're looking at a product page from HDTVSupply
Mhm.
to decode a piece of completely invisible broadcast infrastructure. It's called the AJA FiDO-T one-channel 3G-SDI to single-mode LC fiber transmitter.
Which, I mean, let's be honest, is an absolute mouthful of a name for something that literally fits in the palm of your hand.
It really is. We're unpacking this totally unassuming $585 half-pound box that secretly makes these massive live video broadcasts even possible.
Yeah, and to understand why anyone pays almost $600 for a tiny, like 4.6-inch box, we really have to talk about standard electrical video cables and their physical limits.
Right, it's kind of like a garden hose, I guess. Like if you run a hose for 50 feet, you get great water pressure. But if you try to string together, I don't know, 5 miles of hose, eventually the friction takes over and you just get this sad little trickle.
That is actually the perfect way to visualize it. Resistance in the copper degrades the electrical signal the further it travels. And, we aren't talking about the standard HDMI cable you plug into your TV at home.
Right.
This is 3G-SDI, which, for those unfamiliar, is the heavy-duty, uncompressed video pipeline used in professional broadcasting. It carries a massive, unrelenting amount of data.
Okay, so to push that fire hose of data over long distances, this device fundamentally changes the medium of the transmission, right? How exactly does it do that inside a half-pound box?
Well, it takes that electrical 3G SDI video signal and converts it into light using a tiny, incredibly precise laser. Yeah, and that laser flickers millions of times a second to perfectly mirror the electrical wave, and it sends it down a single-mode LC fiber optic cable, which is basically a remarkably pure microscopic thread of glass.
Wait, so sending light down glass means the distance limit just completely explodes. I mean, you go from struggling to cross a large stadium with copper cables to being able to beam a signal up to 10 kilometers. That's over 6 miles.
It really is staggering. But converting the signal to light solves another massive headache in live production too, which is electrical isolation. Because when you connect complex setups across a huge venue, you often run into ground loop problems.
Okay, let me see if I have this right. A ground loop is sort of like having two conductors trying to lead the exact same orchestra, but at slightly different tempos, right? And the result is just noise, hums, and visual interference in your video.
That's a brilliant way to frame it, actually. Yeah, the differences in electrical potential between the camera's location and the truck's location create that interference, but because light carries no electrical voltage whatsoever.
Ah, I see.
Exactly. The fiber cable acts like a solid brick wall to that interference. The camera is totally electrically isolated from the truck, so the ground loop just completely vanishes.
Okay, so beaming a signal over 6 miles without electrical interference is wildly impressive. But I have to push back here a little bit. Whenever you convert a signal from one medium to another, like electrical to optical, don't you risk stripping out the rich data?
That's a totally fair question.
I mean, broadcasters need their high dynamic range, their HDR fully intact. Doesn't this whole conversion process risk losing that pristine quality?
It's a highly valid concern, and honestly, it's the exact reason why professional gear commands this kind of price tag. This transmitter is built with immense technical robustness. First off, it's format agnostic.
Meaning what, exactly?
Meaning it handles everything from 150 megabit per second trickle all the way up to a 3 gigabit per second flood of data.
So it's not actually compressing the video to make it fit. It's just packaging the exact same raw data into light pulses.
Precisely. And to ensure nothing is lost, it uses something called automatic reclocking. Think of reclocking as a digital metronome.
Okay.
It takes a loppy timing distorted signal coming in from the camera and snaps all the ones and zeros back into a perfect crisp rhythm before firing it out over the fiber. Because of that, it explicitly supports the pass-through of all SDI metadata, so your HDR data travels right along with the video, totally untouched.
Wow. Okay, that definitely answers my worry about the data. And the physical design seems just as bulletproof, right?
Oh, absolutely. It's built for the real-world chaos of live production. It fits seamlessly behind equipment racks, runs on anywhere from 5 to 20 volts DC power, and comes with a 5-year warranty.
Which means a camera operator in the field doesn't have to hunt down a hyper-specific power supply, right? They can just plug it into almost whatever battery system they have on hand. That kind of flexibility is huge.
Exactly. But, all this bleeding edge tech is totally useless if you don't actually know how to integrate it. If we look at the source material from HDTVSupply, what's really fascinating is that the customer reviews aren't even about these technical specs.
Oh, really? What are they about?
Well, buyers are specifically praising the reps, people like Rachel and Mike, for acting as guides through this really complex AV architecture.
That makes total sense. Because when you're wiring a 6-mile broadcast, the human element is just as critical.
Right.
You need someone to ensure the gear works the very moment you unbox it.
Right, exactly.
So what does this all mean for you listening? Well, the next time you watch a flawless live broadcast, you'll know exactly how that video is traveling from a camera on the field to a broadcast truck miles away without losing a single pixel of quality.
It really gives you an appreciation for the hidden architecture of the media we consume every single day.
It really does. Which leaves us with this to think about. If this unassuming tiny half-pound box can flawlessly beam uncompressed HDR video over 6 miles of thin glass thread today, what will the absolute physical limits of our communication infrastructure look like in just another 10 years?